Welcome back, chemistry fans. Today, what we are going to do is try and ignore my son who's working right behind me there. We are going to work on Unit 7, Topic 3, homework. This is lattice energy. This is tough stuff. So I expect you to struggle, but I hope that with a little bit of my help, you're going to find it simpler than what it was before. All right, so let's jump into it. So lattice energy is the amount of energy it takes to split apart a crystal, a solid, to put it back into its individual elements. Well, that process doesn't happen all at once. And so we've got to take these words that are in this one problem, convert them into reactions, and then make heads or tails of it so that we can actually try and add up their sum of their energy. Some of you may want to jump right into the number side of it, and that's perfectly fine. However, that's going to end up getting you the wrong answer 9 times out of 10, because there's going to be one step in this process that usually needs a little bit of adjustment. So I'm going to go ahead and go through this. The first step there, it says, is the heat of sublimation for strontium. So strontium is sublimating. That means that it is turning from a solid into a gas. And so the amount of heat it takes for that to happen is 164 kilojoules. Then the second step in this, it says first ionization energy for strontium. So strontium as a gas is going to lose one of its ions, or one of its electrons. And that process means it's going to have 549 kilojoules. I'm going to scroll down so that we don't run out of energy. The third step says that it's going to be a second electron that is lost. So I start with this strontium that has already lost one electron, and now it's going to lose its second electron. It doesn't do it all at once. And this requires, oops, I can't read it because it's right behind the number 1064. So it's a little bit harder to do that, 1064 kilojoules to make that occur. And then it's saying you're going to dissociate chlorine, which is a gas. And we're going to dissociate that into individual chlorine ions. And in that process of separating, it is going to, have 243 kilojoules of heat. And then the electron affinity. So these chlorines are going to do the reverse. These gas chlorine ions are going to add one electron. Well, in that process, they become just a chlorine atom. Now, they don't like to be by themselves, but that's okay, because we will then add it to the strontium here in just a second. And this one actually ends up being negative 349. Now, here is where we have to pay attention. Here is where the mistake will occur. Notice that this is 2 chlorines, and in this step, there's only 1. So what that means is we need to double that amount of energy, because we need this to be 2 chlorines. By consequence, we would also have 2 electrons, and we would have 2 chlorines here. So we needed to double that energy. Now, for whatever reason, that's not the way they write it in the problems. They're looking for you to make that mistake. All right, the next process is for the lattice energy. So we are going to reverse. We are wanting to create this. So the lattice energy of strontium is how we break it apart. Well, we're going to reverse that. We're going to take the strontium, and we are going to take the chlorine, and we are going to make this into strontium chloride. And in that process, it's going to be negative 2150 kilojoules. Okay, so now we have laid out all of our heat amounts. Now we're going to add all these together to get our final answer. So let me find my calculator. That is 164 plus 549 plus 1064, that looks like, in my ugly handwriting, plus 243 minus 349 minus 349 minus 2150. And that is going to be equal to To form this crystal, negative 828 kilojoules. That's the answer that we are looking for. Now, one of the things that you need to be careful about, to form a crystal, the value will be negative. They could have written this as 2150 because the technical definition of lattice energy is the amount of energy it takes to break it apart. However, in this case, they did us the favor and they actually listed it as the reverse, but we call the energy the same thing. It's lattice energy if you break it apart. It's lattice energy in the reverse if you are forming the crystals. So those are just some of the little details that we need to be able to accomplish as a skill. This is everything that you need for your homework. Thank you very much. Talk to you again soon. Farewell. Bye-bye.